So, it's early morning and you're walking toward your bus stop and notice the cars drive by. You stop and watch and track the car. Now this happens very often, but have you ever stopped and wondered how fast your head is turning as you watch that car? Yeah, me neither. But for the sake of demonstrating mathematical topics, let's find out. So, let's begin. Here's the street, here's the kid, and here's the car. Now let's draw the angle between them. There we go. So I'm going to say it's about 15 feet from the kid to the street, and from the kid to the car is about 25 feet. The speed limit on the street is about 20 miles an hour, which I'll do the calculation for you, is about 29.3 feet per second. Let's mark down the angle from the kid's head straight forward to the car as theta, and the distance from the right angle to the street as x. From there, we know that dx is approximately 29.3 feet per second, as that's the change in x, and d theta is what we're trying to find out. So let's start out with the base equation. Sine theta equals x over 25. We get that using SOHCAHTOA and x being the opposite and 25 feet being hypotenuse. We get the derivative of that, and d theta over dt cosine theta equals. Using the quotient rule, we find that x over 25 has become 25 dx over dt minus x times 0 over 625. Dx over dt being the derivative of x, and using quotient rule, which is low d high minus high d low, all over low times low. By solving further, the equation becomes d theta over dt cosine 0.92, which is theta, equals 25 times 29.3 by substituting dx dt with the actual number we found before, all over 625. You get this 0.92 by going onto your calculator, using the cosine -1 function, the solve for cosine function, and plugging in 15 over 25, or adjacent over hypotenuse. By solving for the cosine, you get 0.92 as the radian value. Solving that fraction gives us d theta over dt, cosine 0.92 equals 1.14. From there, we can solve for cosine 0.92, which is 0.6. So the equation now becomes d theta over dt times 0.6 equals 1.14. We can finally isolate d theta over dt. From there we get d theta over dt equals 1.9 radians per second.